Today we're going to talk to you about what an inverse function is, how to find it, and how to check and make sure that it really is an inverse function. So to give background knowledge, a function only has an inverse if it is 1-to-1. And if it is 1-to-1, there's only one x value for every y. To determine if it's 1-to-1, we use the horizontal line test. In this graph, it passes a horizontal line test because there's only one x for every y.
Something to take note of is that for the inverse, the x and y values get swapped. So for the point 0, 1, for the inverse becomes 1, 0, 4, 2 becomes 2, 4, and 6, 8 becomes 8, 6.
So what exactly is an inverse function? It's a function that essentially is going to reverse what the original function does. For example, if the original function has a square root in an inverse function, you're more than likely going to see a set of values that are squared. Also, something to take note of is that the domain of the original function is always going to be the range of the inverse, and the range of the original function is going to be the domain of the inverse function.
So now that we know what an inverse function is, here are some tips to always remember when trying to find it. Well, you want to make sure that you start by replacing f of x with y so that y equals whatever your function is. This just makes it easier so you don't get confused. Number 2, you want to interchange your x's and y's. So x becomes a y and a y becomes an x. Number 3, you then solve for y. After you solve for y, make sure that you check that it really is an inverse function, and you do this by plugging the inverse function into any x value from the original function. We have a few examples for you.
So the first example we have is going to be is it plus 3?
Plus 3.
Okay. So it's going to be the square root of 10 minus 2x plus 3. As we had just mentioned earlier, the first thing that you want to do is change f of x into y. Okay. And then the second thing that we move on to is going to be swapping the x and y values. So then we have x equals square root of 10 minus 2y plus 3. Once we've reached this point, we're going to essentially try and solve for y. And we do that first by getting the radical by itself. So we're going to subtract 3 from each side. So we have 3 equals 10 plus 2. Okay. So x minus 3 equals the square root of 10 minus 2y. So once we have reached this point, we're going to try and get rid of the radical. Whenever we do that, of course, we're going to square that side. Since we are squaring that, we're going to also have to square x minus 3. Something important to remember is that whenever you are doing this, make sure that you are squaring x minus 3 as a set and not each value independently. So instead of x squared minus 3 squared, we're doing x minus 3 squared equals 10 minus 2y. Alright, and then again, we're just trying to solve for y. So we're going to go ahead and get that by itself by subtracting 10. Which leaves us with x minus 3 squared minus 10 equals negative 2y. Alright, and again, we're just trying to solve for y, so we're going to go ahead and divide by negative 2. Alright, and then this leaves us with the inverse function of y equals x minus 3 squared minus 10 divided by negative 2. Alright, and then So now that we have our supposed inverse function, what we need to do is verify that it actually is an inverse. And as we had mentioned before, step number 4 is to plug this into the original function. So every time that we see an x in the original function, we're going to be plugging in this inverse function that we have. Something else is that whenever you are writing out your inverse function, you want to make sure you switch it back from y equals to f of -1 of x equals that number. So we're going to plug it into the original function. So now that we have our inverse function, we're going to go ahead and plug it back into the original function, which is listed up there. So anytime there's an x in that original function, we're plugging in what we just got. So this will turn into f of -1 of x equals the square root of 10 minus 2 of x minus 3 squared minus 10 over -2 then plus 3. Alright, so I know this can look kind of daunting at first, but if you just take a closer look, it's actually pretty easy to go ahead and break it down. So first we are going to try and get rid of the fraction, and as you can see we have 10 minus 2 times all of this, which is divided by -2. So these two can actually cancel each other out, which would leave us with plus 3. Okay, and now that we have this, we're going to try and simplify it further. And as you can see, we have these two values of 10 right here. It's a positive 10 and a negative 10. So we can actually go ahead and get those two cancel each other out as well. Turning this into plus 3. Alright, so this looks a lot better and easier to deal with. So since we have a x minus 3 squared under the radical, we can go ahead and cancel that out. So since that radical is just taking the square root of this number, and this number itself is already squared by 2, we can go ahead and just cancel that out, meaning that we would end up with x minus 3 plus 3 So, and again, as you can see, there's a 3 and 3 that we can go ahead and cancel out, leaving us with x equals x. And this right here is what is going to signify that it actually is an inverse function. And that is it for me.
So for our second example, we have f of x equals 15 minus x squared over 6. Right, so we're going to replace f of x with y. So y equals 15 minus x squared over 6. And then after that, we're going to swap our x and y values. So this will be really x equals 15 minus y squared over 6. Alright, so now we want to get rid of the fraction. So we're just gonna multiply this by 6 and multiply all this by 6. So then we get 6x equals 15 minus y squared. So we're trying to isolate y, so we're going to bring y squared over and make it positive. Y squared, bring this over, equals 15 minus 6x. So now I haven't solved for y yet, I'm still at y squared. So in order to solve for y, I have to take the square root of both sides. So y equals plus or minus 15 minus 6x. But if you remember at the beginning of the video, we stressed to you how important it is that there's only one x value for every y. But this indicates that there are actually 2. Therefore, this function has no inverse. Cool.
You forgot to draw the radical
Where?
on 15 minus 6x.
Alright, do we thank them for watching?
I think so.
Alright, everybody come show your face. Thanks for watching, and Hudson says the same.